This is Audrey. This is Addie. Are you guys listening?
Okay, thank you. Yep, so this is our video on rational numbers, or excuse me, on real numbers. We have some guest speakers there, so any questions about that in the assessment? We're looking at different types of real numbers. What we're really doing is we're categorizing. It's like saying that a whale is water, but it's also a mammal, and it's also an animal. So it has lots of different names. You could have a beluga. A beluga whale is a special name, beluga. It's also a whale. It's also a mammal. It's also an animal. So there's lots of different names. We're looking at naming numbers, basically, is what we're looking at. There are lots of different types of numbers. We're just going to look at a couple of different categories. These are kind of the big, broad categories that encompass a lot of numbers. The first type of number that we're going to be looking at are called natural numbers. Natural numbers. So in that innermost circle there, go ahead and fill this in, pause if you need to. There's a fancy N. Fancy N is just a fancy way of abbreviating natural. So the natural numbers are all the numbers that occur in nature, like 1, 5, 22. You could have 5 sticks. You could have 22 eggs. You could have 1 something. So these are all things that sometimes are called counting numbers, but they're all things that occur in nature. Positive whole numbers are natural numbers. The next category out we call integers. So we've talked about integers before, we've used integers before, and for whatever reason we use a fancy Z, integers. So a fancy Z because it represents integers. You can either use the fancy Z or write the word integers. Integers are all of the positive whole numbers and their opposites. So it's all the natural numbers and the opposites. Basically, when you look at a number line, like in my classroom, they're all the numbers that you see on the number line. All the positive whole numbers, all the negative whole numbers, and 0 is included in that. And those are called the integers. The reason that we've got these ovals here to show this is that anything that's a natural number, like 5, is also an integer. 5 has 2 names so far. It's a natural number, it's a positive whole number, but it's also got the name of integer because it's a positive whole number or the opposites. So the integers, anything inside this integer bubble here can be called an integer. Anything inside the natural number bubble can be called a natural number. So 5 is inside both of those bubbles. It's inside the natural bubble and it's inside the integer's bubble. So it's got 2 names. It's kind of like a beluga whale is a beluga and a whale and a mammal and an animal. So it has all these different names. It does not, however, work the other way around. Negative 22 is inside the integer bubble, so it is called an integer. But it is not called, you can't do this, it is not called a natural number. It doesn't work going in, because negative 22 is not inside that natural bubble. And so it does not work going in, but it does work going out. Ooh. There you go. Okay. So let's look at another example. Another bubble. So the next outermost bubble, the next type of number that we're going to look at are the rational numbers, which is a fancy Q. Why a Q, I don't know, but it's a fancy Q. So rational numbers are any numbers that you can write as a fraction, as a numerator and a denominator. So you see a couple examples in here. 21 sevenths is a fraction. Negative 10 elevenths, then negative, still there, is a fraction. 4.5 is not a fraction. However, you could write that as, what is that, 20, I don't know, 4.5, 4.5, and so you're looking at 9.5. Sorry, it's Friday afternoon, my brain's a little bit. 9 halves. So it could be written as a fraction, 4.5. 0.3333333 forever, never could be written as 1/3. And so a decimal that either stops, so 4.5 stops, it terminates, or a decimal that repeats can be written as a fraction. 4.5, 0.33333 are fractions and can be written, are decimals that either terminate or repeat, and they can be written as a decimal, as a fraction. It works out to 5, the number 5 itself. 5 could be written as a fraction, 5 over 1. So 5 is a rational number. This arrow just keeps on going out. 5 could be written as a fraction. Negative 1 could be written as a fraction, negative 1 over 1. So anything that's an integer is also a rational number. It works out through those bubbles because negative 1 is inside the rational bubble. That's a rational number. The last one that we are going to talk about, and this is kind of a mix of two, all of these numbers so far are all real numbers. And so the real numbers are written with a fancy R, but there are some real numbers that are not rational. There are some real numbers that you cannot write as a fraction. You cannot write these numbers as fractions at all. These are irrational numbers. And so these are kind of their own little special bubble. There's no fancy symbol, no fancy letter. But irrational numbers are just weird. There are more irrational numbers than any other number. There are more irrational numbers than fractions. So there are lots of them, but they're weird. Like the square root of 2. Square root of 2. Nobody knows, and I say nobody, your calculator doesn't know. Nobody knows what the square root of 2 is exactly. It's this decimal that never repeats and never ends. It's a strange thing. Because remember, square root means that some number times itself equals 2. Well, 1 times 1 doesn't equal 2. 2 times 2 doesn't equal 2. 1.5 times 1.5 is 2.25. There is no decimal that we could say times itself equals 2. Your calculator can give us an estimate, but we don't really know what it is. Same thing with square root of 10, square root of 11, square root of 12, square root of 13, square root of 14, square root of 15. And square root of 16 we can do. That gives us 4. So the square root of 16 is an integer and a rational number. But all those other ones, we just can't do it. Pi is another example. It's kind of like the superstar of irrational numbers, pi. Everything is pi. So pi is out there as well. That's an irrational number. So these are the different types of numbers that we have. I'm not going to deal with what's below. We'll talk about that in class. That blue box down there. But we've got natural numbers, integers, rational numbers. All of them are real numbers. And these irrational numbers are kind of their own little special bubble. Give me some examples. I know you don't have these examples on your sheet. However, we're going to do them. So you can either do it below in that box. It's below it. That might be a good place to do it. Or just somewhere on that page that you have. We're going to give all the names. We're going to write all the classifications that apply to the real numbers, to these three numbers here. So we're going to try and name every single one that we can. 18. If we look at our sheet, at our piece of paper that we just filled in, look at find the pages here, there it is. 18. Is 18 a natural number? Yes, it's a positive whole number. So we can give it the name of a natural number. So we can say this is a natural number. Again, what I'd have you do is, maybe in that box right below all those bubbles, write 18 and below it put natural. This is a natural number. Now we have to look inside our bubbles again and say, okay, is it an integer? Well, yeah. If you can write it as a positive or a negative whole number, we can call it an integer. That's just what it means to be an integer. It's either positive or negative, and it's a whole number. Since 18 is positive, it is an integer. It's either positive or negative. It is positive. So it is an integer. Now we have to decide, is it a rational number? Remember that rational numbers can be written as fractions. So 18, we could write 18 as a fraction, 18 over 1. And so we can write 18 as a fraction, so we can call it a rational number. We cannot call it an irrational number. You can't have something that's rational and irrational at the same time. It can't make sense and not make sense at the same time. Does that make sense? So it can't be both rational and irrational. It's not irrational. You can do it. You've got all the names that apply to this real number. Let's try another one. 8/9. So again, just write 8/9. We're going to name it 8/9 is not a natural number. It's not a positive whole number. It's not an integer. It's not a positive or negative whole number. It is a fraction. So it is a rational number. So we can call 8/9 rational. And that's it. So we got one name. Rational. Not an integer, not natural. Square root of 20. Well, first, if we see a square root, we should just ask, what is the square root of 20? I don't know. The calculator can give you an estimate. It'd be somewhere in between 4 and 5. And it might be pretty much halfway between. So I'm going to guess it's about 4.5. But we don't know exactly what it is. It's going to be 4.5, something. It goes on forever. And since we don't know exactly what it is, it's going to be an irrational number. That's it. We don't know what it is. So that's how we use these terms to classify numbers. So there should be some examples after this. Go ahead and give these a try, and we'll talk about it in class.